Hey guys, today we're going to be reviewing 6.9 integration with substitution. So what we're going to do in this session is basically solve some exercises over here, which is like some of them are definite integrations like this, and some of them are indefinite integrations like this. And then we might do like some extra questions down, which are like higher order thinking questions. So let's get right into it. So basically, question number 1. All right, so basically in these questions over here, the integration is fairly simple. What you got to do is basically every single time you find an integration that has brackets and is to like a certain power, in this case you have to the power of 5. So in this case over here, what you got to do is basically you need to say let u be equal to 3x minus 4. So then du, which is the derivative of 3x minus 4, is going to be 3 dx. So now you got to replace dx in terms of du. So basically you got to say that dx is equal to du over 3, right? Because you're going to divide this by 3, you're going to divide this by 3. So dx is going to be equal to du over 3. So this integration is going to become, instead of the 3x minus 4, you're going to put 5. You're going to put u, and it's to the power of 5. And instead of dx, you're going to put du over 3. So now the over 3, which is 1 over 3, can go out. And you got to find u to the power of 5 du. This integration is basically u to the power of 6 over 6. Plus c, of course. Now before you finish this integration, you gotta replace u back to the same form it was as 3x minus 4. So 1 over 3, 3x minus 4 to the power of 6 over 6 plus c. So then 6 times 3 is going to be 18. So it's going to be 3x minus 4 to the power of 6 over 18 plus c. Similarly, in number 2, see, the most important thing about this lesson is for you to have really, really good eyes. And what I mean by that is the fact that you have to figure out which one you're going to take as u and which one you're going to take as du. Okay? So basically over here, we got 6x to the power of 2 outside and x to the power of 3 plus 4 inside. Notice over here that x to the power of 3 plus 4, if you find the derivative of it, it's going to be 3x to the power of 2, which closely resembles the 6x to the power of 2 outside. In other words, if you are ever confused of what to take as u, always take it as the one inside of the brackets. It usually solves your question if you really, really are confused in the question itself. So let u be equals to x to the power of 3 plus 4. So du is going to be 3x squared dx. So again, basically what we're going to do, we're going to take dx in terms of everything else. Now here's the thing. What I would do in this situation, I try to mix and match what I have and what I need. And what I mean by this is the following. We know that du can replace 3x squared dx. So it can place x squared and it can place dx. However, over here I have 3 and over here I have 6. So if you multiply both of these equations by 2, we're going to get 2 du is going to be 6x squared dx. So now I can fully replace it. So now instead of x cubed plus 4 to the power of 5, I'm going to replace it with u to the power of 5. And instead of 6x squared dx, I'm going to replace it with 2 du. So now 2 can go out, u to the power of 5 du. So then it's going to be 2u6 over 6 plus c. Don't forget to return u as it was. So 2x cubed plus 4 over 6 to the power of 6 plus c. Number 3, In number 3, again, if you're ever confused, just take u as the one in the brackets. So let u be the square root of x minus 1. Now, the derivative of this, first of all, the derivative of the square root of x, it's basically the derivative of x to the power of half. So it's going to be half x to the power of minus half, which is basically 1 over 2 square root of x. So this is going to be 1 over 2 square root of x, and the minus 1 is going to be removed. And of course, you're going to do dx next to it. All right? Now, what I have over here is basically this. I have 1 over 2 square root of x dx. But what I have over here is square root of x dx. I don't have the 2. So how would I cancel the 2 from here? What I would do is basically multiply all of this by 2 and multiply all of this by 2. So then I will have 2 du equals 1 over square root of x dx. So now it perfectly represents this. So now I'm going to do the integration. Instead of square root of x minus 1, I'm going to replace it with u. And so obviously u to the power of 2. And instead of square root of x dx, I'm going to replace it with 2 du. So now the 2 is going to go out. So u squared du. So then it's going to become u to the power of 3 over 3 plus c. Don't forget to return u to the same value it was. So 2, what is u? Square root of x minus 1, all of it to the power of 3 over 3 plus c. This is basically it. Now, in number 4, we got sine x e to the power of cosine x. Remember, all you gotta do is basically think about two values where there are derivative of each other. Okay, so I know for sure that the derivative of cosine x is going to be sine x, negative sine x to be exact. Whenever you have e, always take u as its power. So over here, u is going to be the power of e, which is cosine x. So du is going to be negative sine x dx. So now what's going to happen? The minus is going to go over here next to the du because I want it to be exactly as it is in the original integration question. So sine x dx. So now replacing it, you will have e to the power of cosine x, so to the power of u, and then sine x dx is going to be replaced with negative u, negative du, sorry. So the negative is going to go out. E to the power of u du is still going to be negative e to the power of u plus c. What is u? Cosine x. So minus e cosine x plus c. Number 5, cotangent 3x. Cotangent 3x is the same as saying cosine 3x over sine 3x dx, of course. In this case, you take the denominator as u. So u is sine 3x, and du is going to be 3 cosine 3x dx. So I want it to be cosine 3x dx only, right? So I divide by 3, so then du over 3 is perfectly equal to cosine 3x dx. So it perfectly represents this. So now the integration, when you're going to do the substitution method, cosine 3x dx is going to be du over 3, and sine 3x is going to be u. Now, the 3 can go down next to the u, or can go out immediately. So it's going to be 1 over 3 du over u, which is going to be 1 over 3 ln u plus c. Remember to turn back use the original form of it. So 1 over 3 ln sine 3x plus c. yeah, this is basically it. This is like the main idea of the lesson. So if you understand these 5 questions, I believe that the rest of these questions are going to be easy. So we're going to jump into the higher order thinking questions in 6.9. So in this question over here, they said, if the integration of x over x squared plus 6 dx is 1 over 2 ln x, where k is bigger than 0, what is k? So first of all, from 0 to k, x over x squared plus 6 dx. Remember, what do? You take the denominator always as u. So u is x squared plus 6. So du is going to be 2x dx. But I have x dx. I don't have 2x dx. So what do? I divide by 2 over here and divide by 2. So du over 2 is going to be x dx. And now I continue with my method, my substitution process. So instead of the x dx, it's going to be du over 2. And instead of the x squared over 6, it's going to be u. The over 2 can go out as 1 over 2. And then inside, I'm going to have du over u. And remember that this integration is from 0 to k. So du over u is going to be ln u. So 1 over 2 ln u from k to 0. Friendly reminder over here, you don't add plus c because this is a definite integration. Now, of course, we don't need to forget that we need to return u the same form it was. So this is going to be half ln x squared plus 6. From where to where? From k to 0. So then we're going to get half ln k squared plus 6 minus half ln 6. And this is going to be equal to half ln 6. So take the minus half ln 6 to the other side. You're going to get half ln k squared plus 6 equals ln 6. Okay? So now what you can do is basically take the half as a, you can take it as a power over here. So this can be ln k squared plus 6, all of it to the power of half. This is according to a property in logarithms or ln. If you have a ln x, this can be equal to ln x to the power of a equals ln 6. So ln and ln, you can cancel them out. To the power of half, it's essentially a square root. So square root of k squared plus 6 equals 6. Raise everything to the power of 2. So k squared plus 6 equals 36. So k squared is equal to 30. K is equal to plus minus square root of 30. So in this case, where k, because they said k is positive, that means k is definitely square root of 30 and not minus square root of 30. So this is one question for a higher order thinking question, guys. Be sure to like the video, please. And if you have any questions, you can leave them down in the comments. Thank you.